Welcome to today's webinar. Thank you for joining us. Our webinar topic for today is new customer experiences. A little bit on webinar rules, as always. You'll have your audio muted, but you can use the Q&A function, which is located at the bottom of the webinar window, to ask questions. The questions and the answers, they're going to be live to all participants, okay? And we'll try and answer them as we go if we can. If we don't get to them, we'll follow up with an email to get that resolved, okay? After the webinar. All right. We are proud to feature two companies today, so we're going to have two presentations from our customers, one from Terracon and one from Tetra Tech. I'll be hosting. Some of you might know me already. My name is Paul. I work for Kontur. I'm technical sales for the company, and I'm based in Orlando, Florida. And I'm going to hand over to Mitch Liddell to talk a little bit about Tetra Tech and introduce himself. So, Mitch, if you want to dive in.
Yeah, hi. My name is Mitch Liddell. I work with Tetra Tech in the Edmonton office in Canada. I'm really excited to talk about the system today. We've got it about just under a year ago, so we've got everything that comes with the first year of deployment of the system. So yeah, lots to talk about.
Cool. Ryan?
Yeah, Ryan Korth, Terracon. I'm based out of Omaha, Nebraska, so the center of the U.S. We're nationwide in the U.S. only. We've had our Kontur system just over a year, ground coupled. So yeah, excited to share kind of our learning experience that we've gone through over the past year.
Perfect, thank you. The reason for the webinar today really is, our customers are the best people to tell you about technology and the way that it works and how they apply it, right? So this is the perfect way for others to learn what we do and also what our customers offer as services. So, we appreciate it. Ryan, if you want to go first, you're welcome to share your screen. I'll stop sharing and you can jump in and we can get going.
Sure.
Thanks.
Let's see. Okay. Yeah, like I said, we got our ground coupled system about a year ago. So the main things we had when we have two other multi-channel units. So the Kontur was our third one. So we had some experience with these already. But the Kontur is different, right? Where are we going to use it? Who's going to operate the unit? Is it shippable? Ours is about 6 foot wide. So it's big, it's heavy. And then a lot of what we kind of figure the first part of the conversation is, what does training look like? Who are we going to train? Where do we train? Because it's not like a little portable push cart radar. So it's more pieces. You have to be more careful with it. And then lastly, the biggest question is who has the capacity to process the data? We generally are doing geotechnical work. So we're supporting those projects, and a lot of those sites are huge, right? You go out and collect data for a week and you end up with 50 acres of data. Mm-hmm. So there's considerations that have to be made on how do you transfer data? How do you store the data? Who's going to take all the time to go through all the data? Which just can be overwhelming when you actually get that first huge project. So what we found out was finding people is hard. It's hard to find people that want to travel constantly. We're not big on shipping equipment. So logistics was a big challenge for us. We did ship the Kontur system out to the East Coast one time. We didn't have anybody else to do it. We had to ship it out there for them, and this is what happened. The very first time we shipped it, a forklift ran into the case, right? So this can be detrimental to scheduling. If, say, it was the antenna that got hit, and they put a big hole through it. So that was always a challenge of us. What do we do, right? How do we just drive it around everywhere? Do we have anybody that's willing to go drive across the country to collect data for a few days, drive back, or go to the next job? But we have been fortunate enough, out of order here. We were fortunate enough to find somebody that was willing to do it. So what we decided, we first tried it behind a truck. That's the standard vehicle here at Terracon. And our guys didn't like it. They couldn't hear anything. They couldn't see the antenna. So it was kind of we tried it, they didn't like it, so we went to the next thing, which was a UTV. So we traveled the country in this truck with an enclosed trailer. It's got a UTV in it. We throw the Kontur in the bottom. And then that's how we deployed it. We have a dedicated operator that travels with the equipment. He's willing to go anywhere at any point. But some other considerations were, so we did one project where we scanned basically one lane over 10 miles in a downtown area. That was really the first bigger project that we did. It was for a proposed streetcar. So we were looking for utilities, old trolley tracks that people knew were in various places that hadn't been removed. And we tore through a skid plate in one project. So the considerations were, we didn't have an extra skid plate because we didn't know, right? So he was going from that project to the next one. So we had I'll call it a not great skid plate made for that one, and we figured out a way to make it happen. But that's an important part, especially for ground coupled systems. You don't think you'll wear through them as fast but I mean, we did 4 passes, I think, over 10 miles on rough pavement. The other part of that was a high accuracy GPS. So we were between tall buildings. We didn't do total station when we probably should have, and broken it up more. But we did pretty good. I mean, you can match up manholes and other stuff. We had notes about where we started, but that is a key component to these multi-channel units, is the GPS. It's harder to fix on the back end if you're off by a few feet. And then I would say just adapting to a changing environment. People get tired of driving, people get tired of processing. So right now we have 3 of us that are processing data. This unit's essentially in use constantly, either with travel or collection. So we have a lot of data coming in and a lot of data that people want in short amounts of time. I'm going to go back to the previous one. So we bought the standard cart that Kontur makes. We decided that this was the best option first, at least, before trying to custom make anything or try to mount it onto a little van or any of that. And we had some issues at first trying to get this thing going. But I would say Kontur's customer support is fantastic. I mean, we've spent hours on phone with Paul just trying to figure out the best way to process the data. We also had an issue with the geoscope, which was quickly resolved. We even got a loaner in the meantime while it was getting fixed. So I will say that in general, geophysical equipment companies don't have this kind of customer support that we see on a Kontur. A lot of times, I mean, we have a ton of gear, from seismographs, radars, electrical resistivity equipment, and getting those worked on when they break can be painful. Sometimes it's 6 months before we get the equipment back without really any communication on what's happening, anything. So we appreciate that portion of this. And just to get it quickly resolved, because anytime our gear is not out in the field, we're not making money. So some projects that we've done with this, SUE, we've recently did this one. So we have a standard internal protocol where we require MC GPR on any SUE project, is just the first step, right? Because you can get big picture fast. I mean, this site here, I think it took him, he was there maybe half a day with setup, collection, teardown, where it would take you at least a full day, probably 2 to collect with a standard radar. So we go out, we do this first, find all the utilities that we can, and then we send ground crews in to designate. What a lot of what we've been using the Kontur for is asphalt thickness, both private and public. So a lot of them, they're just worried about thin spots, right? We have an old horn antenna that we used to use for this. It's clunky, it's old, it's hard to use. People don't like it. So we switched to doing Kontur. And actually on the city streets, we've been using the UTV with rolling traffic control. Our guys really refuse to use it behind the truck. Because you can't see it. You might hit a hole or something and the wheel goes in, you might jackknife when you're turning, you don't know. So this was one where we mapped asphalt thickness for, I think it was 8 miles, 4 lanes. So it was a decent sized project.
The map looks really good, Ryan, on the left. Looks really nice.
Yeah.
It's really,
this one turned out really good.
Yeah.
A lot of times we're doing this before they go out in core, so we can pinpoint them on spots where we think it's really thick or really thin. This was just a kind of a test project that we did, where they were just looking for areas under 2 inches of asphalt, which were the blue areas. So it's not full coverage. It was just kind of a trial. But we've done some of these private ones. This one, we actually brought the Kontur in the building. So we didn't have GPS. We just took notes on where it was. But we were out there looking for, this has been patched over the years where panels have been taken out, replaced. So they wanted to know what kind of reinforcement was out there because they drive a bunch of heavy trucks across this. So we did outside and then we brought it inside because they wanted some just general ideas of what was in there. This was a bigger one. I think this was 20 some acres of newly placed concrete. So it was actually QC, because I think the owner, they have a lot of different warehouse type buildings and they've had a lot of pavement problems in the past, so they spend the money up front, and if they have thin areas, they make the contractor actually go and replace them. Before they leave the site, it becomes an issue. Another kind of thing we found that works really good with the Kontur is voids, actually. We've done some like state highway work where they have sinkholes, and nobody wants to shut down a state highway or an interstate for that matter. So we go out with rolling traffic control, we just collect, go back. It takes a little longer, but the DOTs are more willing to do that than shut down lanes. This was a project where they actually suspected water was getting underneath the street because it would rain and then water would come up out of the joints. So we were looking for voids or possible sources of water intrusion along the side, which is what the arrows are. And this ended up being a big void underneath the street. And then lastly, we do a lot of these pre-construction surveys looking for buried debris, landfills. In an urban environment, like in downtown, if there's a parking lot there, it wasn't a parking lot always. So before these guys start construction projects, we'll go out, we'll map out where there's debris or tanks, just so they have an idea of what's out there before they start putting shovels in the ground, and they have a contingency plan on what exactly they're going to get into. I think that's all I have.
A decent sized projects, right? They're all
Yeah.
huge.
I think the biggest one we've done is around 50 acres so far, of full coverage. So we really enjoy it.
Yeah, whoever's the guy that's dedicated to collecting your data is doing a great job of coverage. They're really, really well covered. Normally you see some gaps, but there's not really any. One of the things I was going to ask you is, do the team collecting the data, do they change the collection settings depending on what they're looking for, or do they keep it the same all the way through?
We mostly keep them the same unless we need to go faster.
Gotcha. Yeah.
Some of the roadway projects we go faster just to keep up a little more with the flow of traffic. So we'll decrease our sample rate.
Gotcha.
Because you don't need the high resolution if you're just picking asphalt.
And were you picking asphalt thicknesses before, or is this a new thing that you started doing? You said you had equipment before, but
I would say it's mostly new. We used to use the horn antenna once in a while, rarely, I will say. So it's fairly new. We've done some like little parking lots with like single channel radar, but I would say it's mostly a new line that we're kind of offering to people.
That's great.
It's been
great
successful. So
yeah, and have you thought about bridges yet, or have you not gone into that?
We've done a few bridges. We have a push cart MC GPR that we did several years ago before we had the Kontur. We haven't seen a lot of requests for that, honestly. I think people still like the chain drag for some reason.
Yeah, depending on where you are, yeah, absolutely. But you might see an uptick in this.
We hope so.
In this field, yeah, yeah. I have a couple of questions for you that are coming in from people that are watching. Just one is from Eston about what GPS you're using.
So we use a Leica, I think it's a GS18. We've always had good luck with Leica, so that's what we stick to with the SmartNet coverage.
Yeah, nice. So that everyone's aware, you can use the system is going to use an external GPS positioning system, either live or after the fact. So you can collect data at the time it's embedded, or you can in fact collect positioning and provide it afterwards. For instance, if you had a mobile mapping unit, you could take that mission and apply it afterwards. And in that respect, it's kind of nice because you have, other options, for positioning that are included in these larger systems that are optical. But in general, if you have a nice, good quality RTK NMEA string coming in towards the system, then you're going to be fairly safe. A question about when you're scanning soil, I think. So let's have a look at this. What do we look for when a scan is done on the top of soil? Okay, so how moisture content impact can affect the analysis. Have you done much that's off-road?
We've done a couple. Not looking for moisture though. We were looking for some utilities out, like these grass fields. We did another one looking for a missing person one time, actually, with it.
Did you find it? That's the question.
No, we didn't find it.
But I mean, moisture will impact, of course, moisture will impact, depth penetration, just like any other GPR system. We're not immune to that either. Same parameters. Okay. And what are your parameters, typical parameters that you're using? These are just questions that are coming in. So just typical parameters that you use when you're collecting. So, trigger sampling, distance, things like this.
Honestly, I don't even know.
Sure. Okay.
I think they use 3-inch trigger spacing.
Yeah. That would make sense. So 3 inches. So for those that don't know the system that well, the array, the channels, the sensors are separated by 3 inches or 7.5 centimeters. Okay, so if you use a sampling distance or a trigger spacing that is the same distance as your antenna spacing or your channels are, then you get a square grid, which is a very I would say typical choice. That is really good for lots and lots of different applications. It's a great place to start, and then you can tweak it. Like Ryan said about the speed, you increase the trigger distance, of course, then you have more speed available to you, but less data. Right? Okay. Let's move on. Let's have a look at the time. I'm looking at the amount of time. You are bang on the 20 minutes we were expecting, and that's great. So let's hand over to Mitch. Thank you, Ryan. That's awesome. And Mitch, do you want to share your screen and we'll get started?
Yeah, sure. I'll do that.
Perfect.
My laptop's been a little bit buggy on me, so that's why I've joined twice. Just in case it fails on me, I've sent the presentation over to you, Paul. So if my laptop fails, I can still present it on my phone here, but you could just go through the slides.
Okay.
Maybe.
No problem.
It should be fine, but
no problem. I'll
right.
open it up just in case.
Oh. It's poor practice to not be on the title slide. Sorry about that. Anyway. All right, I'm ready whenever, so.
Yeah, go for it. You should be able
great.
to, yeah, go for it. Yeah.
Yeah, so it's actually a really nice setup we got for this presentation with Ryan going first. They were using a ground coupled, I guess, a Terracon. So we've had the air coupled system. So the two, I guess, classes of Kontur GPRs we can kind of look at. Our experience. My name is Mitch. We're based in Edmonton, my group, and we're sort of focused on infrastructure primarily with this GPR, that being roadways and bridges and things like that. But one thing I'll talk about in this presentation is one thing we like about the Kontur system is it's pretty versatile. So trying to branch out into a number of different things. And I'll show some examples later on. So first of all, the procurement process I'll talk a little bit about. We were replacing an older GPR system here, the Road Radar, that was very proven, like we had been using it for decades. But it was getting older and it was a proprietary system, so difficult to operate and difficult to replace parts, things like that. Our primary focus was pavement infrastructure and bridge decks, and we wanted to replace it with a new system that could promise the same reliability, ideally, and the same volume of data that we were collecting, but ideally improve it. So we kind of went through the different options available and eventually focused on the Kontur system. The multi-channels was a really important thing for us, as well as the traffic speed collection, because traffic control is an enormous headache. If you can avoid it, that's saves money and makes everything a lot faster. The software I was personally familiar with because I'd used the ground coupled system previously, so that wasn't much of an issue for us. But the frequencies available was very important. So not every single GPR has the high enough frequencies we need for those very thin layers at the top of the asphalt, which is kind of the bread and butter of our group. So for the procurement process, we, after looking at what system we wanted to get, we also did some due diligence. This was a test we did in Alabama at the NCAT Center, all these different pavements. And we just wanted to make sure that the data was going to look kind of good enough before you make the investment. And so this down here is a video that I took while we were collecting the data in Alabama. The video is the live driving, and then the data you can see kind of coming in. Plenty of layers. You can even see the different chunks of asphalt as we move from one section to the other. The different colored sections represent different asphalts they were testing. So this is yeah, perfectly good for what we're looking for. In fact, a lot better. So after we got the system, talk a little bit about what the deployment and collection looks like. This is the typical deployment is on the top. We just use it mostly in SUV, whatever's available from our group. This is a Ford Explorer that we've used, but we've used plenty of different systems. We can chuck the whole thing in the back as long as you have a big enough SUV and kind of drive all over the country if you need to. We've also done some off-road stuff. We've attached it here to like a quad. This was for a particular job I can talk about a little bit later, but just looking at racetracks and things like that. So the modular part of it works perfectly good. It's a dedicated system, nice and contained. It's possible to do it with a one-person crew. I've done this many times where I'm the only person assembling it and collecting with it, but it's very difficult. And it's not ideal. It's much better to have, it's one of those things that you can do it with one person in like an hour and a half or an hour or something, or you could do it in 5 minutes with two people. So it's better if you can afford to have a two-person crew. The setup itself, so all the nice images from Kontur, like the promotional images, they always look really good, as you might expect. But the 2.1 meter wide antenna, which is the one we have, so you can get most of the lane in each swath, is really too big and heavy to just sort of float there off the ground. You need to have the straps attached to it to kind of hold it up. And we found that the stability of the floating bracket there, the V-shaped bracket, is a bit of an issue. My best guess is because it's a European system with a 5 centimeter. It's expecting a 5 centimeter ball, which is really close to 2 inches, but not exactly 2 inches. So over time, as we've used it more and more, the tightness when you lock it in on that ball is not as tight as it used to be. So we really do rely on these straps, and we're in testing an improvement that hopefully will deploy. Actually, next week I'm going to test it. Where we can make this more stable, because it works all right, but it's not a long-term solution. We need to make it a more stable solution when you're collecting, hundreds of kilometers at a time. And as mentioned previously, the GPS is really important. There is a half decent internal GPS on the system that's used just for timing, but you can use it if you don't have anything else available. So I've done that a few times before, where the precise positioning isn't all that important. If you're just collecting a swath down the road to get an idea of the road and you don't need to know exactly where on the road it was, the internal GPS is fine. But generally speaking, you do need this external GPS, which is an additional cost. An RTK subscription also comes with that to make it, centimeter accurate or as close as you can get. This makes it possible to get good coverage, like some of that good coverage we saw in the previous presentation. And when you're doing this, a two-person crew really is necessary, just so you can have a driver and a navigator. Another thing that I ran into is the file size issue. So on the left, this is an image of Calgary and some of the roads that we were collecting this last year. And I was collecting with the old parameters I used to use for the ground coupled system, where just to be safe, I would make each file size really, really small. But what that means is when you have a half decently long road, you have millions of these little tiny file chunks, and you have to analyze them each individually. And that took me, I mean, way longer than it needed to. So this is just the learning process where now, after I made this mistake once, I can collect much more efficiently and analyze a lot more efficiently. But these are little things that you don't know until you try them, I guess. So I'll talk a little bit about the analysis of the data. Like I said, our primary focus is pavement and infrastructure. So from my perspective, one of the most important things is this multi-channel collection instead of a single channel, which is the old system we used to use. So I call it like the Zamboni swath, this colored path. This is how much of the road we're getting. And you can see as I scroll back and forth across the channels, the road does change in the lane. And it might be important, some of these small little features we're seeing. Depending on the project, they might be important, and you don't want to miss them. A rather dramatic example is this one. This is a lane I collected, and you can see the depth to the bottom of the asphalt is represented by the color here. So it's a fairly dramatic change. It's probably a trench down the middle of the road, but it wasn't obvious at the surface that there was something like this. So if you have a single channel, you're going to miss this detail. So the layer tracing in the software, I'm really happy with that. It's pretty fast. Other than some very small quality of life changes, I think it's everything we need. It's really easy to visualize things. So this is an example where I'm just picking some, I'm trying to pick the asphalt and the base, and on the right you can see some features kind of emerging, some very deeper features here in red, which might be important to flag to the client because they weren't expecting those. Another example here where we've uncovered this extremely interesting, or from my perspective, interesting deeper feature here. You can highlight that as well. And you might miss this if you didn't have fast enough trigger spacing. So this is over, what is that, 4 meters? I've seen plenty of data collected with the older system that was more than 4 meters for collection. So you could skip over this stuff if you don't have dense enough data. It is important to calibrate the depth to the asphalt, and so coring is an important part of our procedure. We find it when we're collecting for a large network, there's so many different crews collecting so many different types of data. Sometimes the cores get collected before the GPR, which can be a bit of a headache because they're not always exactly where you want the GPR to be, because the GPR can reveal some interesting features that the cores now we've just missed. It's also really important to have accurate GPS for the cores, because we want to know exactly where in the lane they exist. And sometimes this is all done by relative spacing rather than exactly on the GPS. So this is a best practice thing that we need to sort out perfectly, but it can be difficult practically. One thing I'm trying to test this spring is to change the parameters of the GPR as we're collecting so that we can get an idea of the depth without coring. Probably not to replace coring, but just as an additional thing. Our previous GPR had this ability, and I think the Kontur GPR has the possibility too. I just need to play with it and do some tests. So that's something we're going to be trying to roll out this year. Just by altering the transmitter and receiver antennas to make a common midpoint, you can estimate the depth without using a core. This is probably the largest issue we've come across this year. Because we're running an air-coupled system, it's not as shielded as the ground-coupled system, obviously. And I've noticed in a lot of urban contexts, not just one city, but quite a few municipalities, there's a significant amount of noise that we've noticed in urban systems. And you can see the difference in data quality here between the suburban and urban examples. No problem in the suburban, but in the urban, you can get a hint of that asphalt layer probably at like 5 nanoseconds. But this is a difficult piece of data to analyze. Obviously, I would also include a lot of filtering and stuff when I was actually looking at it, but you're cutting out quite a lot of data when you have to do that as well. So it's an issue, and I can't completely solve it. It's just a matter of rather aggressively removing noise and filtering. But this is an issue for any air-coupled system. Another issue, this is not an issue with the system, but an issue of how we communicate our results. A lot of the data that we collect doesn't always, depending on the project, doesn't get communicated, in my opinion, properly to the clients. So on the left is an example of the amount of data we're getting. So this is maybe if we're taking a trigger every 3 inches. In this case, it was 3 inches, or you can see here 7.6 centimeters. And this is the data for every trigger that we're getting. And this would represent, all the colors and numbers here would represent the asphalt thickness at this particular point in meters. And so there's quite a lot of data there, but often clients actually just want a single number in this case, 10-meter bins. So we're taking an enormous amount of data and just averaging it and bringing it down into a single number, which is all they want, all they need for what they're doing when it's part of a larger network. But it's the system's capable of much more than that, and that's something that some clients are really interested in and some aren't. So communication, I think, on the possibility of the equipment is key. So I'll talk now about a few of the applications and projects we've been running the system with. I use this picture quite a lot in different presentations because I think it's a representation of truly the versatility of the system. So this is some of the data with the same system, but you can see all the different targets that we're able to see with just the same swath. I didn't do anything particularly interesting when collecting this data, but you can see pavement layers, utilities, rebar, and bridge decks all in one. So yeah, good sense there. And then, like I said, primary application is pavement. We had to develop a visual reporting system because we have to fold the GPR into some of our larger projects, and it's nice to be able to see exactly where we are on the map and where we are, including our cores and everything all in one visual package. Sometimes it's nice to clients don't want to see the overview of the whole network, but just kind of focus on a small area. So we've developed this. Bridge decks is another thing that, because of the dense data sampling that's possible with the system, we can take seriously. So there's a few different infrastructure issues with bridges that are really difficult. With our old GPR, it would take a long time to collect the data, so much time that it's probably not worth it doing it some of the times, but it's quite easy when you have such dense data sampling. Another thing, like parking lots and racetracks is something we've done with the system as well. So this is where you would collect data in a more dense way than you would on a roadway, and with different collection parameters. In this case, we're looking for voids and things that were beneath the asphalt, because we're planning on putting something quite heavy on the left here. So we were kind of advising on where would be the safest part of the parking lot to use. And on the right, this is looking at how deep the racetrack was to the base layer beneath it, and where it would be safe, where it needs to be repaired, that sort of thing. Kind of a fun project. In some municipalities, there are tree roots that affect the infrastructure. So tree roots we were looking at, we can identify them the same just from context. They're different from pipes because they're going to look a little bit more organic and have slightly different reflection profiles, especially if you can see a pipe nearby. But yeah, so tree roots, this is another infrastructure project that we've been trying to get into. On concrete roadways, so there's an issue in one of the cities we work in where some of these concrete roadways were made perhaps incorrectly. So some of the dowels connecting the different panels might not be straight. And this is a way to do this without destroying the road. So non-destructive condition testing, you can definitely see the dowels with the GPR and kind of cut out that enormously expensive process. And yeah, utilities is something that it's better with the ground coupled system, but I want to make sure that it's possible with the air coupled system too, especially for more shallow things. In this case, you can see this is an unknown utility on the top right here. I'm not sure what it is, but it's very clear. The bottom left is some gas services that we were looking at some, this was in an alleyway, and we needed to know, I guess, how deep these gas services were, whether or not they were installed legally, or they might, because there's a certain depth they need to be, but that might not be possible, or it might not be true. And also you can see some culverts here on the bottom right. So it's definitely possible, even with the air coupled system, which focuses on pavement, to see utilities, and that's something I'm trying to expand into as well. And the last thing here, something I'd like to do in Edmonton, we have a lot of work on ice roads way up north. This isn't something that we tested this winter because very inconveniently I had a baby, so I was kind of off most of the winter. But next winter, this is something I think this system will be really useful for, and that's something I'd like to expand into for sure. So yeah, so in summary, the multi-channel and step frequency system, that's the broadband frequencies that are available with this system, were really the main things that I was looking for in a system. Its versatility is important. So lots of different applications, not just the pavement application. We get our results a lot quicker. One issue we had was fitting our deliverables with the Kontur into the existing workflow for the old system. So that over a few years, we'll be able to make this a lot more efficient internally. But we do get the results out. The urban EM noise is probably the biggest issue with the air coupled system. We can mitigate it, but we can't remove it entirely. And there's still some room for improvement that we're working on. Hopefully next year, this time will be even faster. So thanks. My email's at the bottom right if you'd like to reach out for any reason.
Thank you, Mitch. That was a really, really good presentation, and both of them have excellent examples of, so many applications, actually, different things you can do, and nothing too wild, right? You haven't got to the point of tunnel walls yet, but it can happen. But I think just the variables you can attack in terms of what projects you can take on is pretty incredible. And I really love the utility. I mean, you do see utilities, of course. You cannot avoid them with the air launched as well. In some cases, when the ground conditions are right, you can see very, very, very clearly. And that example is very, very nice, in fact. Okay, I have some questions. We can stick a slide up just to cover this for the second, and we can run through a couple of questions that have come in from the group, if that's okay. Can you stop sharing your screen, and I will just put some slides up. It's not a very interesting one, but it is a slide nonetheless. Thank you. All right, there you go. All right. Okay, let's go through a little bit of Q&A before we start to shut this down. Ryan, we actually got a little bit of information, and both of you can kind of contribute to this, but it was surrounding the processing time, really. So obviously we have two sides of the coin here. We have two products being discussed. One of them obviously being the ground coupled, one of them being the air launched. So that people are aware, the air launched is the one that is most commonly used for pavement assessment because of the speed of collection. It's not touching the ground, obviously, but also the resolution is slightly different, and you're able to trace layers of the ground in a much more efficient way. The ground coupled, however, is a lot more forensic. So it gives you a lot more detail, but can sometimes take a bit longer to plot the layers of the subsurface just because it's really very, very detailed. Okay, so you have a small chip, you're going to see it, right? So it takes a bit more time, I think. But Ryan, how long does it take typically? Do you know how long it takes you to do let's say a mile of asphalt thickness, for instance?
Maybe an hour.
Yeah.
We've gotten pretty efficient. I mean, the layer picking in Examiner is light years ahead of other software that we've used.
Yeah, so we have an algorithm, of course, which you can pick points and it will flood. And you can choose, it will flood across all of the channels, so it will populate as far as it can go. Okay, and then you choose another point, and eventually it will fill out three-dimensionally, a bit like a point cloud, I suppose, right? Or you can even choose single channel. If the requirement is I only want to see one channel from your project, then you could do that as well, right? So even if the project requirement is single channel, the effort to collect is pretty much the same. So you may as well collect multi-channel just in case a question comes in that says, well, I wonder what would happen if we moved a foot to the left or a foot to the right, right? But we also are working on some other tools, and of course, Kontur are always developing. Okay, so in the future, you're going to see developments in picking and mapping subsurface layers. Okay, with new tools that are available now. Okay, so you're going to see new things coming from us. So I'm not going to tell you too much about that today, but that advancement is going to take a big jump forward very soon as well. Okay, so keep your eyes out for that one. I have another question, so let's have a look at this one. Maximum speed. What's the maximum speed to get a reasonable resolution when you're looking for voids under the pavement? And what is the maximum depth where you have detected voids under the pavement?
I think the maximum depth that we got, it was a sinkhole project down in like Karst area. I think it was like 3 feet
Mm-hmm.
for that one. I think we were going 10, 15 miles an hour.
Yep.
So reasonably fast. We try not to go too fast, otherwise you do lose resolution.
Yep. And a little bit about the size of void, which is, there's a question about size of void here, but it's actually a little bit of a tricky question because it depends a little bit of depth as well. So it's hard
Yeah.
to say, but the system can be, you can change the parameters to take samples more often in your traveling direction. Okay. So if you're looking for things, if you have a little bit of pre-awareness of what's affecting the pavement, you can set the system up accordingly. So, you know, if you know that they are larger voids, right, they're typically big, and you're having these kinds of issues already, then you can set the system to take samples further apart, which will give you a speed benefit. But if you know it's very, very small and very subtle information you need, a bit like a bridge deck where you want to see all of the steels, then you want to go smaller, and that's going to slow you down. And that's typical for any system. You need more time to gather more detail. Right? Another question about how, I mean, this is for both of you really, how are you handling the volume of data that you collect, and how do you get it from the field back to the office? How are you guys handling that situation?
We use
Ryan,
OneDrive actually.
do you really? Okay.
Yeah. And it's a little painful, I think, for him to upload from hotel internet, but
Hmm.
downloading it, we haven't had any issues so far. When we bought our first multi-channel unit 5 years ago, we used to actually ship hard drives back and forth.
Hmm.
But internet speeds have improved. So
What about you,
Uh,
Mitch? What do you
yeah,
do?
it's usually, I mean, we collect the data on the day and then download it to physical hard drive, and then that, yeah, we just bring the physical hard drive back and then keep all the data kind of local to the machine it's using on, or that we're using it on. We haven't had to upload it to send it to a processing crew or whatever back home, because we don't have yet a processing crew that's separate from the collection crew, which is all me. I do it. So when
Hmm.
I'm ready to process it, I have the hard drive. That's not actually the bottleneck for me. The a thing that kind of slows me down in Examiner is when you have hundreds of kilometers of data, it can really slow down the computer. So I have to think thoughtfully about how to separate one of the larger projects into manageable bite-sized chunks that I can actually process, and do that in a way that makes sense. So I sometimes do that just by day of collection, unless maybe I've collected all over a city and I want it to be physical instead. So you have to be a little bit thoughtful about that. There's certainly a, a maximum amount of data that can be in a project for it to run smoothly.
Hmm. Thanks, guys. So there's some really good questions here, by the way. So thank you for contributing. Let's have a look here. Question about CMP. I guess this one's one that I can answer for you. So whether Examiner is able to display and process data that is collected via CMP. Now, just to move backwards a step. The system, of course, is an array, so it has transmitters and receivers at set distances apart. Okay, which does offer itself up to a common midpoint collection. Okay, and of course, the system has been used in this way for research projects and other applications, and in fact, for different industries, especially rail, things like this. Okay, where people do use this. All right, so it's absolutely possible with our system to use it in this way. You can create any combination of custom scan pattern you choose. Right, that's absolutely possible. In Examiner, however, we haven't got official support for it just yet, but as always, we are always pushing forward to follow where the customers are going. So the more and more requests we get for these things, we're always following that, a bit like our customer support. Okay, so wherever the customers are moving, the requests are coming from, that's where our attention is going to go. The CMP is something that we are focusing on right now. You can't touch it too much in Examiner. It's not going to be something that you can handle. Okay, so you're going to have to do that outside of Examiner. However, that's going to be short term, all right, because there is stuff that we're developing to help in that direction as well. Okay, all right. Bit of a long answer for a short topic, right? The speed, this is kind of interesting. The speed that you were driving, I don't know if you're going to remember this, Mitch, but the speed you were driving when you saw the underground utilities, right? Because there's going to be an attraction here. Seeing some utilities with an air launched antenna makes everything easier, right? Because one of the problems is touching the ground, right? So, what type of speed? Do you remember what type of speed or an estimate of what
Well,
sort of speed you would have been
yeah,
going?
yeah. So those gas services, though, I was going very slowly because we are looking for them, and we're in an alley. So I don't know. It was something like 15 kilometers an hour or something. It was very slow. I think we could have gone faster, but it's just we're limited by the area. If you're doing utilities, you need to go slower because you're looking for you kind of being more careful and hoping not to miss something. I think you can see utilities if you're going faster too. We've certainly seen them. Typical roadway that I'm collecting on is like I like to go 50 kilometers max, but you can still see utilities. It's just that that's not your primary focus. If it was your primary focus, probably you'd be going much slower than that. I've seen now. I remember seeing somewhere on LinkedIn. This is a while ago. Someone collecting data like over 100 kilometers an hour with the system. So I guess it's possible. I've never done that, uh, but I think it's possible. And it's like if you need to because of road concerns or you don't have traffic control, I guess it's possible. But for utilities, I would want to go slow. Yeah, like 30K max probably. And that's not because of the speed; it's because of the other parameters that you're choosing, like the trigger spacing, especially the trigger spacing, so that you don't miss something.
Yeah, and also because of the depth that you're trying to achieve, and also that the infrastructure can be kind of complex, you know. So you and utilities has a different type of risk. So it has a very different approach, I think, when you start to look at utilities. But I understand the question. It's very attractive to see it coming from the air launched unit. But Kontur are not making the air launched unit specifically for utilities, right? But you will see them anyway. Okay. But I would recommend the ground coupled antenna for utility mapping. Really. Yeah. Okay. Let's have a look through the list. We have how deep can be scanned with the ground coupled and air launched. I mean, this is a bit of a difficult answer to give because it really depends on what the ground is made out of. What you know. And that can vary even in the same, similar location that you're working in. So everybody's going to have a different answer here. The air launched, however, it's really built to do the construction thickness of the road, right? It's going to be the first meter, something like that. Okay, but we're also collecting data at road speed, so it's fast, but it's designed to give you the construction thickness, right? Okay, full construction depth. Okay. With the ground coupled, from my personal experiences when I was surveying as a contractor, our requirement was to be 3 meters, to cover 3 meters, and in London and UK, that kind of areas, we would typically be at 2.5 to 3 meters fairly consistently. So it was kind of straightforward. We have another product that's available not in the US, but it's available in the rest of the world, called a deep antenna, which has larger, more separated elements, and it also has a lower frequency. Plus, it has a focus on signal to noise ratio, where you can get a lot deeper. So if depth is a thing that you're concerned with, or it's difficult ground conditions you want an improvement on, that's a product that you might want to be thinking about. Okay, so depending on where you work, right, that's really the answer. Okay, let's have a look down. Is it possible to detect debonding and stripping between two asphalt layers? I'll give that to you guys, Ryan and Mitch. Welcome to answer that one.
We haven't tried, I guess, is my answer.
Mitch, seen debonding, stripping between two layers?
I think it's possible to detect it, but that's not what we've been primarily looking for. They haven't had a project for that.
Okay. From our point of view, of course, we see lots of studies through research efforts and pooled fund studies with DOTs and other things that we have seen it many times. Where you have debonding between two lifts of asphalt, for instance. And the advantage with the channel, the multi-channel system, again, is you can see the geometry of something, right? So you're less concerned with the two-dimensional radargram, and you kind of focus on the horizontal slice to start to pick out areas that you can see. Okay, I can see something that's unusual looking there. So you can go straight to it. It's kind of interesting, but yes, you can, and there is a study at the moment on stripping in the US, which is a pooled fund which has a number of states involved. We will see more and more information about that. So keep your eye out on that stripping study, which is led by Minda. Yeah. Thank you for attending, and thank you, Shaya. I appreciate that. Let's have a look at some others. Bear with me, I'm reading them just quickly before I read them out in case there's anything odd in there. Hey, Payman, he's asked, this is Payman from Caltrans, have you identified sinkholes with the air-launched antenna? Have you seen any of those? And do you suggest an air-launched or ground-coupled antenna for that practice? And if so, why? Have you done any sinkhole investigation with either of those that you and then which one would you suggest?
We've done sinkholes incidentally, not we weren't looking for them, but we were looking at, I'm thinking of a particular parking lot that we were looking at just to see what the structure was. We did identify some very small sinkholes that were right at the surface, so the air launch was perfectly fine for that. I think if you're looking for something more dramatic, probably the ground coupled is safer because you're going to see deeper.
Yeah, I think I'd agree with that as well. I think if you just want the depth, if the sinkholes are located at depth, then I think it's the ground coupled. But I've seen similar. I've seen very nice examples of sinkholes with the air launched. But it really depends on again what your ground conditions are like. I know that in the Asian region, for instance. Where the ground conditions are a little bit more difficult for penetration, then the ground coupled and our deep antenna is very useful for void detection, just because it gets has a little bit more resolution and penetration. It's a bit more stable in their ground conditions. So it really depends a little bit, but yeah, deeper ground, shallower. Just underneath the pavement, for instance, then you'd be okay with the ground with the air launched. Yeah. Okay, where are we with time? Okay, we're nearly there. Any other questions that are remaining? We'll come back to you. So apologies we didn't get to them. But I'm just going to finish off by thanking our two presenters and their companies. We really appreciate it, and we're very proud of you proud to have you as customers of Kontur, as we are with all of our customers. So thank you for doing that, and thank you for joining us today. It is recorded. You'll get copies of this. If you have any questions aimed at the Kontur technology, then feel free to reach out to us. Support channel, sales channel is also there if you're interested in purchasing or finding out more information in that respect. And if you have a local sales channel, which is typically outside of the US, then please contact your representative and discuss with them. But remember to also follow us a little bit on the social media type of channels, because that's where we do a lot of updating and communicating about what we're releasing next. you're going to see some software releases this year and some nice efforts in overcoming some typical difficulties that are out there in the industry that we think are going to bring enormous value and quality control, for instance, in pavements and things like this. So keep your eyes peeled, because there's a lot from Kontur this year. Okay, but once again, thank you for our thank you for our guests for joining us. Excellent presentations, and thank you all for spending some time with us today. And we'll see you again shortly. Thank you.
Thanks, Paul. Thanks, Ken.
Thank you.
Thanks, guys. Thanks, Ryan.